Assalamualaikum and a good day for all panels and audience. It is an honor for me today stand in front of you to deliver a presentation. I would like to present about the course of MEC602, the final year project 2. Before that, let me introduce myself first. My name is Nur Aiman bin Amran. I'm the Bachelor of Mechanical Engineering student from University Technology Mara, and my final year project's name is Investigation of the Mode Expansion of a Car Front-End Module. I have been supervised by Dr. Muhammad Nur Hisham bin Abdul Rani and also Professor Madya IR Dr. Muhammad Azmi bin Yunus. Hopefully, this presentation will give you guys the overview of the project as well. So let we start it. Go through further, this presentation is cover about 5 main chapter and following with subtopic. Starting with project summary, introduction, methodology, result discussion, and closing with conclusion. So project summary. This project is performing experimental model analysis on a geometrically complex structure such as a car front-end module. It is very difficult and challenging because the difficulties arise because the responses on the certain degree of freedom cannot be measured due to the limitation of the space for accelerometer with a proper orientation will be mounted. Then, the unmeasured DOF, natural frequencies, and mood shape will be measured using 3 different experimental model analysis EMA by using SERAP expansion method. Lastly, the accuracy of the expanded mode shape is quantified and evaluated by performing model assurance criterion MEC analysis. The outcome from this work is expected to provide useful guidance for obtaining the unmeasured DOF of a geometrically complex structure. So let we move to the first chapter, introduction. Before we go to introduction, let me explain first problem statement and the objective of this project. To be specific, front end module of a car will definitely vibrate when a resonance occurs. It causes a structure to suffer bad damage. The phenomenon of the resonance occurs when the natural frequency of the structures is coincide or equal to the natural frequency of the external forces. The model parameters such as natural frequencies or mood shape of the car front-end module is essential information for the dynamic analysis on the structure. Experimental model analysis EMA is used to investigate the responses on certain degree of freedom of the car front-end module, but it is difficult to obtain because of complex geometrically structure due to limitation for placing accelerometer with accurate orientation. Therefore, in research and validation, the use of expansion process such as SERAP expansion is used conventionally in expanding the real-time data calculated on the front car module. This approach is also capable of obtaining full result of DOF that are difficult and unmeasured on the car front-end module. So the objective is to develop the finite element model to determine mode expansion method by using 3 different EMA model to evaluate the accuracy of the expanded model of a car front-end module. So let we go to the introduction. So now we in chapter 1, which is introduction. Generally, a vehicle, especially a car, whose component consists of various structure in an important element in involvement with vibration phenomena. Adoptedly, in almost all actual practical situations, structure with complex geometry will experience difficulties and inconsistencies in the comparison of measurement between finite element and experimental model analysis or testing. Usually, the incompatibility appears due to 2 different things. First is that only a certain degree of freedom can be measured. Second, not all mood shape can be measured. The difficulties arise due to limitation for placing accelerometer with accurate orientation. Besides, the data acquisition equipment also makes the frequencies range to be measured have a limit. Then the finite element method is widely used and conventional. This method could be very large, to several thousand degrees of freedom can be measured in some cases. Thus, the difficulties that arise can be overcome and solved by using mode expansion method. In performing the expansion process, there are four main techniques used, but this study only focuses on the use of serret expansion that implemented on the three different model EMA. And then the accuracy of the expanded mode shape is evaluated and quantified by using model assurance criterion MEC analysis. Okay, now we in chapter 2, we'll discuss about literature review. I have highlighted some essential elements that related to this project. First, for finite element model or finite element method, Said Rao SS in the finite element method in engineering, Henneman 2017. The finite element method is basically the most frequently and effectively used to model the complex structure like as bridge, building, dam, containment vessel, and others. Then GKJ Golinval also revealed that dynamic behavior can be explained, understood, and modeled with an effective instrument, namely experimental model analysis, and it can also determine the natural frequencies and mode shape on the complex structure effectively. Second element is the mode expansion method and the model assurance criterion. A few researchers said that in structural dynamic research, such as vibration-based structural health monitor, the mode shape expansion is very useful. But the result of the expanded mode shape can be inaccurate if the experimental mode shape do not mesh well and correctly with the analytical mode shape. Then lastly, in order to produce the transformation between master and slave coordinate, Serap used theoretical eigenvectors. It is very precisely related to the expanded mode shape. Okay, so now let we move to the methodology in chapter 3. Okay, now we in chapter 3, which is a methodology. We start with description of the test structure. This project is implemented on the front-end module of a car. As a case study, this structure is used because its configuration is considered to be the main and important role in the vibration level of a car. There are 9 components located on the test module installed using 76 welded joint of resistance as shown in a figure. The component range in thickness from 1 mm to 1.4 mm, and all the components are made of galvanized steel. The component also have an overall weight of 2.45 kilogram and its length is 960 millimeters. Okay, so in implementing the finite element model in CAE software MSC Patran, 2D shell elements are used in the expansion of FE model as shown in figure. Since the geometry of the test module is so complex, several variations of element size are used in range of 5 mm to 8 mm. Therefore, in the creation of the FE model of the test module, a total of 6,010 nodes and 5,530 elements were developed and consists of young modulus of 210,000 megapascal, portion ratio of 0.3, and density of 7.850 kilogram per meter cube. So the experimental model analysis begin with arranging all the equipment as shown in figure. As you can see, the test module is suspended using 2 soft springs to simulate the configuration independently, while a 21.56 millivolt per Newton shock hammer with 3 improper 10 millivolt acceleration is used for measurement. The test module is also connected to the SCADA measurement system, LMS, To obtain the dynamic data after the test module is tapped at all points that have been determined to obtain the complex EMA model. Then the experimental also was set with a frequency resolution value equal to 0.5 Hz and a frequency bandwidth with the range between 0 Hz to 512 Hz. In the success of this work, experimental model analysis is used to measuring the natural frequencies and mode shape for the test module. So, for development of the mode expansion method in EMA, the mode shape of the test structure can be expanding with the help of element model FE, where the expansion method is implemented toward the FE model of a car front end module. Basically, it starts with the first configuration, which is the complete measurement configuration, where the measurements are taken at all locations on the test structure. Next, the measurement is made in the middle of the body of the test structure, referred to as middle only measurement. In addition, for both side only measurement, that is the third measurement is done on both ends of the car front end module. And finally, known as 1D line measurement, is made at the line point that have been determined. Then there is only one technique applied in expansion mode method for expansion process for this work, namely as serif expansion. Serif expansion can determine the unmeasured and difficult mode shape. The serif expansion method also is applied by using software according to the equation below. So now in this chapter 4 is discussed about the outcome of the project. There were 52 points response was measured by 2 roving accelerometer. The test structure was completely excited 10 times to obtain a good and reliable data result. The test structure was done to obtain the complex EMA measurement by comparing the determined model parameter with their measured counterpart. The developed finite element model accuracy was evaluated. In order to calculate the accuracy of the mode shape, the model assurance criteria MEC was carried out because the structure geometry can be considered complex. Other three measurement configuration is obtained from help of 8 FE model of a car front end module and implemented a mode expansion method by using software based on selected point on the measurement configuration. So, based on 3 measurement configuration, tabulate data in MEC value for middle only measurement configuration. In these two figures, after shape were expanded, particularly its slightly reduction in first, second, fourth, and fifth mode after the mode shape are expanded. Okay, now let's talk about both side only measurement configuration. In a comparison as shown between this figure before and after, the high MEC value approaching 100 were found in the first and second mode before the mode shape is expanded. However, the diagonal value of MEC was increased and approaching 100 after the mode shape was expanded. With 99.6%, the second mode is the largest contributor to the 68.12% total average MEC percentage after expanded. The fourth mode shape also recorded the lowest 96.6% MEC values compared to the other modes. Okay, for one D-line measurement configuration, figures below show the comparison between initial FE in column and a one D-line measurement configuration in row before and after the mode shape are expanded in terms of MEC values. Okay, from the observation, the MEC values for all modes approach 100 before the mode shape are expanded. except for the first mode with 65.5%. However, there was a devaluation of the MEC values after the MEC shape are expanded. The diagonal MEC values are not close to 100 or 0. As you can see in first mode, second mode, third mode, fourth mode, fifth mode, and sixth mode. The devaluation is due to the lack of selected node or point and inaccurate selection of point location. But as a result, it was proved that the nodes or point on the structure analyzed in the experimental model analysis EMA are sufficient to expand at the middle only and both side only measurement configuration of a car front end module. Okay, now we in the last chapter, which is conclusion. The average MEC values before and after the expanded MOOC shape for each configuration should be determined for finding the accurate measurement configuration for a car front end module after implementing the mode expansion method. The accuracy assessment of the expanded car front end module EMA model was quantified using model assurance criterion MEC analysis. As a result, both side only measurement configuration shows the highest average MEC value with 98.12%, whereas one D-line measurement configuration shows the lowest average MEC value, which is 53.87%. According to the result, the measurement configuration with the highest accuracy of the mode expansion on both sides only was the best when compared to others measurement configuration. The effectiveness of the project's work can be enhanced by ensuring that the 3D CAD model is drawn well and accurately. Furthermore, prior the performing mode shape expansion, the selection of the appropriate and adequate point on the experimental model analysis is essential in producing accurate and good result. Therefore, to this validation, the mode expansion method is the most appropriate to be implemented on both side only measurement configuration of EMA model in complex engineering structure. So the objective of this project was successful achieved. Okay, last but not least, I'm very grateful to Dr. Muhammad Nur Hisham Abdul Rani and all members of the Structural Dynamic Analysis and Verification SDAV team, School of Mechanical Engineering, College of Engineering, University Technology Mara, UiTM, who provided a lot of guidance and support throughout the success of this research project. For any requirement or question, you can directly contact or email me through information provided below. Don't forget to subscribe, comment, share. Thank you for watching.